Welcome back to Detailed, an original podcast by RCAT. This is a show where we uncover lessons learned to help you navigate your next project. I'm Cherise Lakeside, Senior Spec Writer at RDH Building Science, and your host. My guests today are Philip Castillo, FAIA, Managing Director at Jahn, with offices all over the world, and Benjamin Skelton, President of Cyclone Energy Group. Philip Castillo, FAIA, has over 40 years of experience leading complex and diverse architectural projects around the world. As Managing Director at Jahn, he oversees all aspects of design, planning, management, and systems integration, ensuring that the original intent is carried through every stage. His portfolio includes global landmarks such as Sony Center Berlin, Shanghai New International Expo Center, Tokyo Station Yaesu Development, and 1000M in Chicago, alongside innovative smaller-scale works like the Harold and Margot Schiff residences. A fellow in the American Institute of Architects since 2010, Castillo combines technical rigor with design clarity, a perspective shaped by his studies at the Illinois Institute of Technology and his decades-long tenure with Jahn since 1978. Benjamin Skelton is the founder of Cyclone Energy Group, a Chicago-based firm dedicated to optimizing building performance. Since starting the firm in 2012, his team has gained international recognition for bridging the gap between design, construction, and operations on landmark projects. Benjamin's award-winning portfolio involves driving decarbonization in existing buildings, enhancing the efficiency of everyday facilities, and helping design pioneering high-rises and net-positive projects. The project we're talking about today is the Pritzker Military Museum and Library in Summers, Wisconsin. Designed by Jahn, the Pritzker Military Archive and Library in Summers, Wisconsin is a purpose-built facility that brings together precision, functionality, and public engagement in a single cohesive environment. A disciplined 36-foot structural grid organizes the building, utilizing an exposed steel glass system that creates a tight envelope, preserving the thermal stability required for long-term collection care. Now, let's get into the details. My guests today are Philip Castillo, FAIA Managing Director at Jahn / I'll ask you about that later, with offices all over the world, and Benjamin Skelton, President of Cyclone Energy Group. The project we're talking about today is the very cool Pritzker Military Museum and Library in Summers, Wisconsin. So we always start our interviews with a little icebreaker question to get us warmed up and get to know you a little bit. I would like to know, and I picked these out of the air, just whatever floats my boat that day. I would like to know, what skills have you learned on the job that school didn't teach you?
Phil, do you want to go first?
Oh, Ben, I was going to say, why don't you go first? But I'll go first.
I
think, I went to school a long, long time ago, and, it's changed since then. But I think the biggest thing was really about collaboration. And it's not collaboration among architects and design professionals, but as in the Pritzker Military Museum and Library, it's a collaboration with the contractor and everybody who believes in the same mission.
Guessing you're much better at that these days.
Yeah, I think I am. I would like to think so.
How about you, Ben?
I can still be ornery.
No.
You'll fit in good around here.
Yeah, I guess things I didn't learn in school that I've picked up on the job, just running and managing my business has been how to motivate people, not just for collaboration, but to get the most out of them and kind of enable other people to do that. You learn to teach yourself at school a lot of times, but you don't really learn how to teach others in this practice, at least. That's something I've definitely picked up on, is how to get the most out of other people and motivate them to enjoy what they do.
I love that you said that, because I really feel like my entire career, that mentorship in the architecture profession, at least, has not been what it could be. A real like intelligent focus on the best way to mentor younger professionals, which is more important now than ever before because we have a very large generational imbalance right now. So a lot of young people in our firms, then not enough of us still left in the workforce to teach them. So yeah, very important thing to work on. Let's talk about this project. So Pritzker Military Museum and Library. How about we start with a little background and history on this project? Like what was the driver to make this facility a reality?
Well, the driver to make this a reality was the Pritzker Military Museum and Library, a backlog of information being books, uniforms, medals, artwork by soldiers in the trenches, uh, ammunition, firearms. And this was all being stored in an area in Chicago in an older warehouse that did not have the correct climate controls or any of the other necessities needed. So they felt a desire to build a ground up facility for storing all this archival material. And that's how it started. And as the project uh, developed and as we were working with them, we added a kind of an anteroom in the front where you come in, and that became an exhibition area. And then there was this plaza for ceremony. So as the project evolved and the program evolved, it became more than just an archival storage facility. And the complex was much bigger. It had um, it had this pavilion with these kind of concrete boxes on either side of them that were for storage and for future other commercial archival storage, but it ultimately got narrowed down to a 17.5-acre site. And that site has the building that you see today with the archival storage in the basement. Should also say that, originally Colonel Pritzker bought a little over 200 acres that extended from the east end of our site all the way to Interstate 94. And the intention was to put a uh, firearms education center, otherwise known as a gun range, and a sporting clays course, which I always akin to uh, foursomes with rifles. And ultimately, through many meetings with the community, it got scaled back. They did build a firearms education center on the far west of the site, and then there's our building on the far east of the site that will ultimately have a monument to the Cold War, which they're raising money for now, and it will also have it does have a solar field which will get expanded, and there's almost a backstory to the solar field, and that is we originally had all these solar collectors on the roof of the storage buildings, and then when it became one building, we had it on top of the building. But what we learned was because the museum was a not-for-profit and the building was actually a not-for-profit site, they could not sell excess energy back to the grid. So we put the solar farm separate, which is actually more efficient than having it on top of the building, so that it could be a separate entity that would then be able to sell excess energy back to the grid.
Yeah, and you're able to have more solar generation too. When it was on top of the building, you were limited to the footprint. And this didn't come up on this, but a lot of warehouse projects were storing precious materials. They don't like to have solar panels on the roof. It can be a fire threat or a life safety threat to that building. So this was neat that it got moved off the building. Although it was pretty neat when it was one building and it's kind of incorporated in the glass system. That was really cool.
Interesting. I didn't know that there were restrictions for nonprofits
Yeah,
for
there
something
are. I
like that.
mean,
You would think it.
I guess that's why they're nonprofits. They have to balance the books every year.
It seems to me if they could make more money, they could help more people. But that might be just common sense. So before we get into building like specific pieces and parts of the building, give me a broad description of the scope of this project.
Okay, the building is a 46,000 square foot facility with 26,000 square feet of exhibition space, research offices, processing, and back of house like book restoration and 3D imaging in 26,000 square feet. In the basement below is 15,000 square feet of archival storage and another 5,000 square feet of conventional mechanical space. This building then sits on a 17.5-acre site that was meticulously designed by Tom Osland at O2 Design, which is a landscape architect. And the references to all these things were all military inspired.
So this is a really unique combination here of guests on my show. It's usually like just a single architect or an architect and an owner, architect and a contractor. But today I have an architect and an energy/comfort consultant. Ben's bio says that Cyclone Energy Group bridges the gap between design, construction, and operations. And I think operations often don't play enough of a role in our conversations during design. There's definitely conversation around it, but maybe not enough conversation. So tell me a bit about this collaboration between the two of you and what you were looking to achieve together.
Sure. Yeah. A lot of what we do is to look at how the building is going to operate once it's built. So we'll do a lot of modeling to understand how much energy it's going to use, what kind of environment it's going to have inside of it. We use a software IES virtual environment for most of our modeling, which is a great, powerful tool that lets us look at not just energy, but we can look at the actual thermal comfort of the space. This project being a very glassy building, having archival elements to it, people actively working on types of things that Philip's described here that can be damaged by the sunlight, for example. Like, we need to model that to understand in reality, how is it going to affect that? How is the glass going to work? Do we need a different pattern on it to get rid of different wavelengths of ultraviolet light? And that was one big part of this project, was to study that, so that once the building was in operation and running, we weren't finding out after the fact that the sunlight was deteriorating elements of artifacts. And we did do the forward modeling of that in the software when the project was being designed, but after it was built, before the acceptance of the building, we went through with actual meters and validated the performance of the glass system that we modeled, and found just that it was actually outperforming what we predicted it was doing. So that was a real pleasant validation of the work that we did there. And then, of course, on the energy side, the building's got to be conditioned 24 hours a day, 7 days a week. How much energy does that take? What is it going to cost to operate the building? That was something we studied and modeled. And then, how much are we now offsetting with the solar generation as another part that we were able to use our modeling to validate after the fact once things were in operation.
So, Phil, was this new to you? I mean, I worked in MEP for a long time. I'm not new to energy modeling, but this looks like energy modeling on steroids. This is another level.
This is something that we've always been doing even back when Jahn was still with us. I don't like to use the word sustainability. I mean, sustainability is permission to play these days. I like to say that we work on buildings that perform at a higher level. And if you look back at the work we've done, you'll see that the performance has always been kind of a generator of design and engineering, and we look at it as a synthesis. So this is nothing that was actually new to us. It's something that we started right from the beginning. Even the mechanical engineer, the MEP engineers we hired, we wanted to make sure that they had a rich resume of archival storage, because we don't need to reinvent the wheel on a lot of these things. Now,
I now work for an enclosure consultant. I'm going to be quoting you today in the office. I love that comment about sustainability.
And we always, Helmut believed this, and I'd been with him for a very long time. that seems to be this one material that keeps on improving. You know, the sophistication of the coatings, and in this case, the addition of frit, which has been around for a while, uh, all work together to improve the performance of the envelope.
Yeah, it very, very much was integral to the whole project from the beginning. That the Beyond team really had so many ideas and so many iterations of this project that we weren't just doing one model, one idea. We were comparing dozens and dozens of iterations of different glass combinations, different frit patterns, different orientations of things on the building. So it was really, a study to kind of find out what worked best throughout the project. It was, you know, and echo what Phil said here. And, it's high performance buildings are what we're trying to do, and this team really knew how to push that envelope.
Yeah, I can't keep up with the glass, to be perfectly honest. It's changing so fast, which is not the case with every building material, but it's all good changes. Go ahead, Philip.
Excuse me. You get some companies like, Viracon provided the glass for this building, but you get other companies like Guardian or Interpain or Tivitec in Spain, and they will actually tweak the coatings to improve them. It's not like coating A, coating B, coating C, take your pick. And so they'll work with architects and engineers to actually fine tune their coating so that the sophistication of the glass and the performance of the glass continues to improve. I mean, this glass, what we always work with our mechanical engineer is solar heat gain coefficient. This has now seemed to become more important than shading coefficient. And on this building, it's actually 0.22. So that's a very high level of performance for solar heat gain coefficient. The exterior reflectance is like 9%. So, this has an added feature because that low reflectance, it increases bird safety, which, we're out here in the prairie, and that's an important element that we have to consider.
Interesting. Let's start getting a little more specific. I typically just start from the outside, work my way inside. So let's start with this site. Tell me, what did you have to work with? And were there any challenges with this site or special considerations? Or I saw something about preserving some adjacent wetlands. Oh boy, do I have a story for you about wetlands, but we won't go into that now. Um, Tell me what you had to work with on this site.
We had to work with a gently sloping site from west to east and east to west. And further down from the west on the western mid part of the site, there was a creek that went through that had some limited wetlands, not really impacting us too much, although we had to control runoff. We had 17 and a half acres. It was a soybean field. So the effort was to kind of reintroduce this idea of prairie back to the site, but in a more sophisticated way. As Tom Osland always says, is that the generator for the landscape was really this kind of defensive mechanism in the military, which was this rampart, which is this larger circle that you see going around the site. And not only that, there's also other concentric circles of walkways. And then connecting this circle from one end to the other are these two allays of oak trees. And so, and then through those allays, there's commemorative benches and things of that nature. Obviously, we needed to have retention, but the retention ponds on either side, east and west, are actually used for irrigation, so that we're very limited water is used for irrigation outside of what we can control in the retention ponds. And for those who know, prairie plants are very sturdy. They had to be sturdy, right? And they still are sturdy. So, they kind of live with the cycles. And within this circle was placed this building. And as you move around the building, there's parking east and west, and then there's a celebration plaza in the front with the 7 flags. And I remember when Helmut and I made our first presentation to Colonel Pritzker. We had the American flag in the middle, and we had the armed forces on either side. The first thing she said to us was, the American flag is on the left, and then you have the Army, Marines, Navy, Air Force, and you're missing the Coast Guard and Merchant Marines. So we had a little bit of a military history lesson there. And so you see the flags there, and then there's a plaza. And what they do on this plaza is, like, during this Memorial Day, Veterans Day, any of these military holidays, they actually have a ceremony out there. People from the neighborhood come, or people associated with the museum. And it becomes part of what the uh, what the entity is on that site.
So going off the rails for a moment, is the plan, because you talked about some of the future construction plans here, is the plan to have a like full-blown kind of complex of different places to come visit and learn more about our military?
Yes,
And like, because you talked about the Cold War thing.
there was the Cold War Memorial. They had a competition, and an architect and artist in Los Angeles won, but I believe, and that is, another circle which intersects with our circle, a tangent to the rampart. And then there's the solar field, which would expand. They did build on the far west side a firearms education center or a gun range. And part of that is that you can take arms from the archives, some of these older pieces, these older rifles and things, and use them in the fire range. So
Wow.
there is part of this whole kind of connection with with military history. The building itself was actually informed by amphibious landing craft that were used in Normandy. It's not exact, but it is kind of a reinterpretation of that shape.
I can see that. Well, let's talk about this building, because this is a striking facility. I remember when somebody sent for the podcast, they sent this over and asked me, do you want to do this? And I didn't even read what it was about. I just saw the picture and I said, yes. I don't know what it is. I'll go do my homework, but yes, I want to talk about this building. Largely that cantilevered roof really just makes it just scream at you, hey, I'm here and I'm gorgeous. Describe the exterior design of this building and some of the more unique materials that you used.
Well, there's not much in unique materials. It is steel and concrete and glass and a metal deck, an acoustic metal deck roof with a conventional roofing system. However, that being said, the whole idea was that this building was rough and tough, like a piece of military equipment. All the bolts are exposed. We didn't grind down the welds to make it perfect. We wanted this to be just kind of a tough structure. And then this kind of pristine skin is more of the discipline, right, of the military. So the idea was that we had these two parallel trusses. They're about 360 feet long. They sit on 7 pins, and they kind of slope just a little bit outward. And then infilling this is a fairly standard steel structure on a 30 by 30 foot grid, 36 by 36 foot grid. Because the building was one story, we could leave all the steel exposed, so it's just a painted steel structure. The 7 pins are kind of important because, we wanted the loads to come down on the vertical cords of the trusses. However, Pepper Construction, the contractor, figured out that they could use these pins to fabricate these trusses laying down and then lift them up to form the building. And literally one day the structure was all down on the ground. The next day it was up. And it was I went to this lifting of the trusses and it was very cool. They had 3 cranes with red and green lights and a guy with an iPad standing on the slab. And his job was to make sure that the lights were always green. And if one's lights turned red, they had to, they stopped because they couldn't have any torsion in any of these trusses. So it was kind of uh, it was choreographed like a dance, but the structure itself is really the architecture.
Okay, so this project is in Wisconsin. Never been there myself, but I'm familiar with it, and they have some really cold winters there. And so I'm looking at this building and I'm thinking Wisconsin. Um, this is not your typical enclosure on this building. This is a lot of glass. How, with that much glass, I'm just dying to know how you kept your enclosure design energy efficient, because I believe they get pretty hot in the summers as well. Energy efficient and maintaining that interior comfort, and then the added special things you need for the preservation and all of that with that much glass.
Well, let's start with what the criteria is, and then I'm going to turn it over to Ben. The criteria was that we needed to be at about 68 degrees Fahrenheit, plus or minus a degree. And the relative humidity needed to be at 45%. I think it was like +2, -1, if I recall correctly. 24/7, both levels of the building. So that was the design criteria that the engineers had to work with. And, like I said before, it's the sophistication of the glass that makes this possible. Ben,
So fill me in on the details, Benjamin.
Yeah, it's not just the glass, but also the shape of the building contributed to that. The cantilevered roof and things like that added elements of shading that help with the summer. That was one thing we looked at, was when the sun's setting. If you drive up, you haven't been to Wisconsin. If you drive up to Wisconsin, it's a big flat area, and you can see this coming from a mile away, and it's really striking how it comes out of the land, but it is exposed, and it's exposed to all of the wind, the rain, and especially the sun, not being shaded completely around the building. So the building itself creating its own shade helps with some of the load factors to reduce the amount of energy we'd have to offset. And then the design engineer did a great job, very creative design to distribute the air from underneath the floor. To one, it keeps, I think, duct work and things out of the space itself. So it's aesthetically pleasing that way, but it also is a very effective way to wash the sides of the building to keep any kind of thermal energy coming into the building that might be affecting the archival artifacts and activities that are happening in the space. So we did model this from like a comfort perspective using our software, and made sure that we were maintaining those conditions at all times with the types of design. We're able to see, uh, you know, how the distribution would work in the space. We didn't do any computational fluid dynamics modeling or anything like that, but we did do uh, modeling to the effect of making sure that the occupied areas, the spaces that were going to be affected, stayed within those ranges.
The as Benny said, the all the air distribution is at the perimeter, with the exception of this little core. Everything is at the perimeter.
Mhm.
And then we always believe in these taller spaces that we should allow the air to stratify. And you only need to really cool the first or condition the first 2 meters of space. After that, who actually cares, right? You can just we just don't want 2 meter spaces throughout our world. So we have a series on each side of the east and west side. There are a series of operable vents. They do two things, say, for smoke evacuation, but they also, if there is too much excess heat, we can dispel it to the outside.
Nice, because there's glass on all sides of this building, correct?
There is glass on the east and west side, which is heavily fritted, and the frit is there to represent this kind of structure, and also for more energy reasons. On the north side, there is no frit. It is just the coated glass. On the east side, on the south side, it is probably, I would say, 65% metal with a clear story above it, because that's where the
And it's
loading
also the
docks are. I
smallest
mean,
portion
all
of
the
the building.
louvers for the mechanical systems and emergency generator, on and on and on.
All the pretty stuff.
Well, we made the back look pretty good with all that pretty stuff. I mean,
Yeah,
it's just, everything counts. And then
yeah. I was.
there's this steel trellis on the top of the building, which is, I it's akin to a cornice, and that extends over this ceremonial plaza, but also goes around the perimeter of the building, so you get this other constant data above the roof line.
So I'm before we move inside the building and talk about some of that, I'm curious from your just like standard building to doing a facility like this that's, you know, museum, library, you've got some special considering. What are the unique considerations for a building like this that you wouldn't have in your average building if there is such a thing?
I think that the temperature and humidity demands, because that in the end drives everything, and you just don't have these in buildings. I mean, in Germany, the buildings we did in Germany, because of the way the German laws are written, you have to have a certain humidity level in an office or apartment building that you would not have to deal with in the United States. But archival storage is kind of an animal amongst itself, and so it has certain things, and ours is almost kind of an average, because if you have uniforms, you'd have a different, or fabric, you'd have a different criteria than if you had paper or that you had metal. So we had to kind of take that and average it out so that we could kind of catch everything.
And add to the temperature and humidity requirements that, you know, the first floors very glass oriented and lots of daylight, which think about what museum have you ever been to that is a lot of glass? Usually there's no glass. Everything's kind of hidden behind dark walls and in spaces. In this case, that's not the case at all. And so having that element is very unique because now, again, we need to control the ultraviolet sun waves that come into the space in addition to the temperature and humidity constraints. And it was a challenge to look at.
Well, that was one of the things that surprised me is that it was all glass for the kind of building it was, because that's just not what you usually see because of that archival storage and those deep requirements. So we're going to go inside and we're going to start with the basement, where all the monsters are, the basement. This building includes 15,000 square feet, from what I understand, of below grade archival storage, exhibition, and research areas.
Just archival storage.
We've talked, just archival storage. Okay. And we've talked about some of the unique climate control requirements. Tell me about this space. And what you had to do and what you did down there in your design to make it what it needed to be for that archival storage.
It is literally just a basement. Okay. Now, there is some point where you can take advantage of the natural cooling of the earth. Right. I don't think we're quite that deep, but it's a fairly deep basement. And it was just concrete walls, and we have ductwork that was running along the east and west side that was feeding up, but it was also feeding down. One of the biggest challenges was we originally had a dry sprinkler system in the basement, and that kind of went away for a number of reasons. And so there was an additional trench drainage system that was added along for the entire length of the building, I think spaced equally across the width, so that if the sprinklers did go off, the water would not start collecting. It would just go directly off. And but other than that, there was, other than just maintaining temperature and humidity, it's a large basement. There was one special room that was kind of like an ice box where they kept glass plates and films, and another room that was locked where they kept firearms. And then adjacent to it,
And I
immediately
think
to the south, was the mechanical plant, which I don't know. When I saw the photos, I've been in it, as the cleanest mechanical plant I've ever seen in my life.
It very much is very clean. And one of the things my team commissioned the building before it opens. We tested the building systems to make sure everything works correctly. The mechanicals that Phil's talking about. And one of the requirements the contractor had, Pepper Construction asked us to take a look at, was to validate the asymmetric temperature differences. So the temperatures at basically every single 6-inch element up from the floor in the basement to the ceiling of the basement to see how uniform it was. And we don't want the stratification in the basement where the storage can be up shelving. You want fairly uniform. So that was one of the unique requirements of the project, was to go through and validate that we had this temperature grid that was even and distributed throughout the space.
So let's talk about interior aesthetics a little bit. Describe some of the other interior spaces in the building and some of the unique design features and materials that you used around the building.
Well, like I said, we kept it simple. You walk into the building and you see this 36-foot structure. And what we did was we painted, it was all the columns and primary beams on a 36-foot grid are painted red, including the truss. All the intermediate beams are painted black, so that you've got this kind of order of structure as it goes through the building. About 70 feet in, 72 feet in, there is a core. It's essentially a drywall box that extends up about 12 feet. And within it, there's a catering kitchen. There are toilet rooms. There are meeting rooms. There's a research room and other offices. And that is the gypsum board is painted gray, but there is a black expanded aluminum screen around it so that you get this other kind of ethereal feeling. When you see it, it has kind of soft edges, even though it's very hard. The floor is all um, just epoxy. It's kind of a deco flake epoxy, so there are no joints in it. It's beautiful. You go in and it's just expansive, one surface. As you get to the south side of the core, there are 2 glass walls and doors that are secure public area from the work area. So they didn't want people. They wanted people to be able to see in, but they didn't want people to go through there. And then behind there is where the staff process new material that's coming in or getting ready for material that is going to be sent off to an exhibition somewhere or borrowed by another institution. At the south end, then, there's a loading dock, various electrical rooms, and an elevator down to the basement, and a scanning room, a 3D scanning room where they take every piece that comes in and they scan it. So they have a digital record and then the physical piece. And a book restoration room, which is in one corner, and it still takes advantage of the glass. And that's allowed so that if books that come in that are precious and damaged, they can be restored. Then opposite that, on the other end, is a workshop where they build crates to move things around. It's very simple and logical.
Is this actually open? Yeah, well, I'm looking. I only have a couple of pictures of the interior. Is this open to the public, that kind of museum?
Yes.
Or is it really strictly centered around archival? Oh, okay.
No, it's open to the public. It is open to people doing research, military research. And it's kind of, an interesting, it's an interesting place to go. I remember at the grand opening, they had there was this cartoonist who drew caricatures, Bill Maudlin. He drew these all while he was in the trenches, and they had all this displayed. And that you could go and read these things. It's absolutely fascinating. They have, the old World War II and World War I posters that that you've all seen. Some of they have some of the original artwork for this. It's the original watercolors. It's really fascinating stuff. So it's open, I think, 4 days a week, and the public can go there and see the space, enjoy it. The grounds can be enjoyed anytime. And, researchers, I believe they just make an appointment to get there.
So for each of you, from your different perspectives and roles on the project, What would you say? I love to talk about challenges because I think we grow the most as professional from the challenges. The easy stuff's easy, right? What would you say was the most difficult challenge to work out in this design or in this project, and how did you navigate it?
For for me and our team, one of the most difficult things to work out was going through different iterations of the solar designs, the solar panel designs. So we again use this IES virtual environment modeling software, which let us do lots and lots and lots of iterations of things. But what no software could do was understand some of the concepts that we were studying. And one of the earlier concepts, the roof of the main archival building at the time was glass, and the frit pattern was made actually out of solar collectors that were built into this custom glass. It was an amorphous silicone material that uh, uh, the Jahn office had kind of designed into a unique pattern. And so, that isn't something that you buy off the shelf. And we had to figure out how to model that and study that and determine how much energy it could produce, in addition to looking at a combination of that with typical solar panels as well. I think the challenge for us was just all the iterations we had.
Every building has its challenges, and I think the challenge on this one was to really get everything right, and one of the things we really, you know, y yes, we had to solve the structure with our structural engineers and the mechanical system and made sure everything, worked from an energy standpoint. We did have as Benny said, we did have a glass roof, and for cost reasons, that was changed to a solid roof, which I think made the building better. But I think what we really worked on was the pattern of this frit and worked on what the density of it. The red is much more dense than the black. It is slightly offset because we didn't want a joint, a glass joint in the middle of the red vertical. So you get the kind of pleasant result is you get this kind of interesting layering of, the structure and the glass. And then you still have this kind of view to the outside. So, that may have been the more challenging aspect of it.
So, construction, there's always fun in construction. I have yet to see in my career, which has been lengthy now, one project that didn't have interesting challenges or surprises that came up during construction that needed to be solved. I don't like to call them problems because there's just it's just the nature of the game. Building a building, things are going to come up that you have to work around. Tell me about the construction phase and share with me at least one construction challenge that you faced and how you dealt with it.
I don't know, this was pretty smooth, I have to say. It was when I would come up there to go to the owner architect contractors meetings, I'd always stop at the superintendent's trailer and, we'd have some cookies and coffee, and he was an older Italian guy, and he'd talk about his tomatoes, and we'd talk about our families, and he'd say, "Phil, let's go out on the site. I want to show you some things." And we solved those problems right there. And that was kind of the beauty of how this whole thing worked.
How
Yeah.
about you, Ben? Was there
Oh,
anything that came up for you?
no, and I agree with Phil. This is rarely does this happen where we have a project go so smoothly. And from our team that was commissioning and testing the building systems, there's always a war story on a project about something that went wrong or didn't work out. And we don't have any good stories from this one. The contractor Pepper Construction did a great job of coordination. The trades that worked on the systems were all responsive, and I think I, everybody had maybe a sense of pride to working on the project and spent that extra time doing it. The challenges we had during construction were just validating the things that we'd modeled during design, and we were really happy to go through that and never found a real problem.
The other thing we did was, and this was probably the last thing Helmut saw before he passed, was we had a full scale mock up of maybe like 15 feet in height of the glass and the steel so that we could make sure it was right before we did, before we embarked on this big adventure. The other thing we did was GSI, who was the facade contractor, we had various big glass samples that Pepper's one of their offices in Barrington, Illinois, where we had the big glass panels where we could actually make sure that the color was right before we got to the other mock-up. So, mock-ups are really important, and that's how these projects like this become very successful.
I You have a fan here, trust me. On those key systems, a mock-up will save the day every time. But it sounds like, excuse me, it's a real testament to not just your contractor, but your team and the collaboration on this project. You always know when you're on the right track, when things are going smoothly, because we don't get to say that a whole lot. We
No,
just
that we
don't.
don't, and this is one of these projects where, everyone was swimming in the same direction. There was no question about it.
Isn't that a concept? In an industry where we need every member of the project team for the project to be successful, we're just starting to learn to collaborate appropriately and correctly. So I'll ask each one of you this. I love to ask my guests this question because I think we grow from every project we work on. What was the biggest lesson you learned from this project specifically that made you a better architect or a better professional on the next project?
Biggest lesson learned, it's, I think the biggest lesson learned here was just how well a team can work when everybody is on the same page about things. And in the design phase of this, we would meet at Jan's office very, very regularly to go through the design concepts. This was a challenging project for us because things were constantly changing. We enjoy that and appreciate it. That's what makes it fun. It's not just a one-time thing that we're working on. It's constantly evolving, and I think just going through that process and the collaboration that we had with the design team, it was really something that I hadn't experienced in this kind of fashion before that worked this well.
How about you, Philip?
I think, much the same. We had a team that worked well together, and you don't always get that. You'd like to think that every job is going to be great, but every job is not great. And this one, we had great collaboration between all the design professionals that were involved in this project, from structure to energy to MEP systems, landscape architect, lighting. Everyone, that was it was really a joy. And then when you layered in a contractor who really understood the structure and how this whole thing needed to go together, that helped. But it never works unless you actually have a client that believes in the same mission. And this client was really stellar in helping us and supporting what we wanted to do as a design professional.
Well, congratulations to both of you on that, because I think that those occasional projects that are a true joy are what keep us at this. So before we get to our two closing questions, tell me, this is your chance to kind of toot your horn and tell us what's going on. Tell me what both of your firms are working on now that I get to call you later and say, okay, I want to hear about this one.
Before I jump into what we're working on now, I'll take a step back. We just finished a high-rise building with Phil in the Jahn office in Chicago, and we had a sustainability awards ceremony, and we were having lunch afterwards. And someone asked the question, "What's your favorite project you worked on?" And, the Pritzker Museum was my choice instantly. It was just such a fascinating project and so much fun to work on. We've worked on some really neat projects over the years, some real groundbreaking zero energy, zero carbon projects. But what's keeping us really kind of excited and busy right now is we're kind of branching out a little bit from the high rises and things that we normally work on, and starting to get into some more in-depth studies where we're looking at embodied carbon in buildings and doing that kind of modeled carbon analysis with our softwares. And that's something we hadn't had a lot of clients do before. So one of those projects we're working on is the revamp of the Chicago Union Station. Um, that's one of these that's coming out, and then we're looking forward to more projects like that in the near future. We're seeing a lot of increase in that kind of thinking about, do we tear down a building or do we reuse a building or do we create a new building?
It is barreling forward in that arena. I mean, I'm hearing it from all different areas. So you're going to be busy. I promise you that. How about you, Philip? What's Jahn got on the boards, so to speak? Although nobody's got boards anymore.
I still do.
Oh, good.
Our biggest project right now is Google's Chicago headquarters. And the interesting thing about this project, this was the James R. Thompson building, which was the state of Illinois' office building that Helmut designed in 1984. And we were retained as the architects for its repositioning. The building was stripped down to the structure. So with the exception of the steel structure and new steel that was added in certain areas, it has a new mechanical system. It's a LEED platinum building. Google's told me in the beginning they start with LEED platinum and only go up from there. The building is really like 95% glass, 90% glass. It's all triple glazed. It has all those things that Google is known for, because dealing with their sustainability group and their ecology group, and this was a true learning experience. And that's 1 million square feet. At the other end of it is, I was just in New York last week at a client's house, Francis Greenberger, who was the client on the residential tower that Ben mentioned, and another residential tower we did for him in Lower Manhattan. He has a project in Chatham, New York called the Pavilions at Art Omai. And what Art Omai is, it's in Ghent, 15 minutes away, is a sculpture garden, artisan residency program in camp. And then he had this other 100+ acres in Chatham. He decided to do the pavilions at Art Omai, which are architect, artist designed pavilions, and they're all different. And I had the honor of working with Alice Aycock, the artist who does these massive sculptures. They're really phenomenal. I had her commissioned for a building we did in Washington, D.C. So we've become friends and we've collaborated on this pavilion.
I might need to hear about that one. So you may have to come back if I can convince you. So I always
I can always come.
Oh, good. Oh, good. Well, you said it. So do not get annoyed with me when I'm going, hey, Phil, okay, I just read this thing.
The only thing I can't talk about is Google.
I already knew that. That's why I didn't even bring that one up. I'm familiar. That's all I'll say. So I always close with two questions. The first of which being a broader industry question. I like to ask my guests their opinion on one thing to maybe share with our listeners. So staying on theme a bit today, when it comes to bridging the gap between design, construction, and operations, what as an industry could we be doing better?
Yeah, I think as an industry, that having worked in a traditional MEP environment, an architectural environment for many years, what I saw lacking was more feedback from the people in the buildings after you've made them and created them, and how they operate, how they run, how efficient they are. All these factors come into play. How accessible they are, how easy they are to maintain. These are things that we don't always bring backwards into our designs. We're always thinking forward about the next great design, but we can inform a lot from not just near-term history, but long-term history of older buildings and things before there was air conditioning in conventional heating systems in buildings. There's a lot of lessons we can learn from the past that I think and bring into our designs and concepts now to make them more passive, more have more longevity to them, and be more accessible to everybody.
What do you think, Phil?
Well, this may sound a little mundane and maybe a little bit conceited, but I think many more problems could be solved in the field if an architect made a sketch in front of the contractor and handed it to him and said, this is how it needs to be done. And we forget about all the paperwork that's involved, or I have to go back and do it on the Revit model. So many things can be handled in a much more simple manner. And I see that's missing. And when we interview young architects, I want to make sure they can make a sketch.
I couldn't agree more. The unfortunate part, being a person who works on contract documents all day, is that we live in this very litigious society that we have to, the handshake deals and just working it out and let's move. Unfortunately, we're not allowed to do that. And I don't know how maybe we change the risk model in our contracts differently to where everybody's got skin in the game. And
probably wouldn't hurt. And I think that was the beauty with Pepper. When I went to Fred's trailer, we solved problems. And Tom Oslin, the landscape architect, would say the same thing. We solved problems. He said, let's go look at this. And there was never a paper trail. It just got solved. If it needed to be ripped out and redid, a sidewalk piece or that's what happened.
I'm going to pretend I didn't hear that. I'm being traumatized right now. Just my job. Sorry. So final question. And we ask every single guest that's ever been on this podcast this question because I'm a big marshmallow and I want to know. I hope that we all hope to live a life that in some way leaves a contribution to make the world a better place. Small or big, personal or professional. What do you hope your impact will be?
Yeah, for me, the impact is every project we do as a company. And the reason I even started my company almost 14 years ago was to have positive impact in everything we touch. And our vision is to make the world more efficient. And that can be in a lot of different ways. It doesn't have to just be energy efficiency, but we're trying to make high performance buildings. And so I think I don't see me personally or my firm having one shining star of an impact. It's the combination of all the stars that we put together. Every single project we have has a positive impact. It's a better performing building than it would have been if we hadn't worked on it. And so I'm always really proud to look at the skyline of Chicago and the other cities we worked in and say, we worked on that building. We helped it be better than what it could have been.
How about you, Phil? How are you going to change the world? What are we going to remember?
Well, I think we'll just remember that this buildings fit into their context. They are enjoyable places to live, work, play, experience. And I think that's kind of the one singular goal that I want to see happen with every building I work on.
Gentlemen, I can't thank you enough for joining me today and talking about this. It's really incredible. I mean, it grabbed me the second I looked at it. So congratulations on your process and the building itself. And I hope you'll both come back and tell me about more. You don't have to wait for an invite. You can just drop me an email and say, Cherise, I got something you're going to want to see. And I'd love to have you back on the show, but I really appreciate your time today.
Thank you.
Thank you. It's been great.